ಅಂತೂ ಇಂತೂ ಸೂರ್ಯನತ್ತ ಯಶಸ್ವಿಯಾಗಿ ಆದಿತ್ಯ-L1 ನೌಕೆ ಚಿಮ್ಮಿದೆ. ಯಶಸ್ವಿ ಉಡಾವಣೆ. ಈಗಾಗಲೇ 4 ಹಂತಗಳನ್ನು ದಾಟಿರಬೇಕು. ಆಗಲೇ ನಾವು ಬ್ರೇಕ್ಗಳಿಗಿಂತ ಮೊದಲು 3 ಹಂತಗಳಾಗಿತ್ತು. PSLV C-57 ಆದಿತ್ಯನ ಕಡೆಗೆ ಯಶಸ್ವಿಯಾಗಿ ಪಯಣವನ್ನು ಮುಂದುವರಿಸಿದೆ. ಸತೀಶ್ ಧವನ್ ಬಾಹ್ಯಾಕಾಶ ಕೇಂದ್ರದಿಂದ ಶ್ರೀಹರಿಕೋಟಾದಿಂದ ಉಡಾವಣೆ ಆಯಿತು. ನಿಗದಿತ ಕಕ್ಷೆಯಲ್ಲಿ ಸಾಗ್ತಾ ಇದೆ PSLV C-57 ನೌಕೆ. ಸೊ ಭಾಳ ಗಮನಿಸಬೇಕಾದಂಥ ಸಂಗತಿ, ಯಶಸ್ವಿಯಾಗಿ ಹೋಗಿ ಏನಾದರೂ ಅಲ್ಲಿ ಕೂತ್ಕೊಳ್ತು ಅಂತಂತಂದರೆ, ಎಲ್ ಪಾಯಿಂಟಲ್ಲಿ ಕೂರ್ತು ಅಂತಂದರೆ ಅಲ್ಲಿಂದ ಅದರ ಸಂಶೋಧನೆ ಶುರು. ಚಂದ್ರಕ್ರಾಂತಿ ಆಯಿತು, ಈಗ ಸೂರ್ಯಕ್ರಾಂತಿ. ಈ ಮುಖಾಂತರ ಏನು ಅಂತಂದರೆ ವೈಜ್ಞಾನಿಕ ಕ್ರಾಂತಿ, ವಿಜ್ಞಾನ ಕ್ರಾಂತಿ. ಮೊದಲ ಬಾರಿಗೆ ಸೂರ್ಯನ ಅಧ್ಯಯನ ಶುರುವಾಗಿದೆ ಭಾರತದಿಂದ. ಬೇರೆ ಬೇರೆ ದೇಶಗಳು ಇದಕ್ಕಿಂತ ಮೊದಲನೇ ಶುರು ಮಾಡಿವೆ. ಏಕೆಂದರೆ ಅಮೆರಿಕಾ ಪಯೋನಿಯರ್ನ ಬಿಟ್ಟಿದೆ, ನಾಸಾ ಯುರೋಪ್ 3 ಹಂತಗಳಲ್ಲಿ ಉಲ್ಲೇಸಿಸನ್ನು ಬಿಟ್ಟಿದೆ, ನಾಸಾ ಯುರೋಪ್ ಮತ್ತು ಜಪಾನ್ ಸೇರಿಕೊಂಡು ಸೋಹೋ ಬಿಡ್ತು.
ನಿಮ್ಮ ಉಬ್ಬಿದ ರಕ್ತನಾಳಗಳ ಸಮಸ್ಯೆಗೆ ಎವಿಸ್ ಆಸ್ಪತ್ರೆಯಲ್ಲಿ ಕೇವಲ 30 ನಿಮಿಷದ ಲೇಸರ್ ಚಿಕಿತ್ಸೆಯೊಂದಿಗೆ ಮುಕ್ತಿ ಹೊಂದಬಹುದು. ಹೆಚ್ಚಿನ ವಿವರಗಳಿಗಾಗಿ ಸಂಪರ್ಕಿಸಿ 8088837000.
ಇನ್ನು ಸೌರ ಜ್ವಾಲೆ ಅಧ್ಯಯನ ಮಾಡಲಿಕ್ಕೆ ಸ್ಟೀರಿಯೋ AB ಬಂದಿದೆ. ಸೂರ್ಯನ ಅತ್ಯಂತ ಸಮೀಪಕ್ಕೆ ಸಾಗಿದಂಥ ಮೊದಲ ನಾಸಾ ನೌಕೆ ಪಾರ್ಕರ್ ಅದು ಯಶಸ್ಸನ್ನು ಕಂಡಿದೆ. ಆದರೆ ಭಾರತದ ಈ ಸಾಧನೆಯಲ್ಲಿ, ಅಂದರೆ ಭಾರತದ ಈ ಪ್ರಯತ್ನದಲ್ಲಿ ಒಂದು ವಿಶೇಷತೆ ಇದೆ, ಅದರ ಬಗ್ಗೆ ಮಾತಾಡ್ತೀವಿ ನಾವು.
Effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements. And apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres? And how does Aditya-L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to 27 arcs to 10 to 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, what there are 2 unique instruments built by URO Satellite Center that is going to cover the solar flares from 1 kV to extremely high energy, around 200 kV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these 2 instruments, along with the other 2 instruments, VLC and SUIT, we are going to address this $1 million questions as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya-L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya-L1 absolutely unique, because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the ASPECTS payload, which stands for Aditya Solar Wind Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know, because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. And therefore, we should know in what direction the plasma is coming and whether the plasma is getting accelerated in between when it comes from sun towards earth. And therefore, there is a multi-directional information which is available from the ASPECTS payload, because it consists of 2 sensors, SWIS and STEP, essentially giving you in 2 different energy bands. And therefore, we'll be able to quantify the CME, CIRs, and all the process which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally we move on to the principal scientist, Dr. Sankara Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like Astrostat and Aditya-L1?
Yeah, so now ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. And that is something which especially a heliophysics community could utilize it, because we can, at a low cost, we can launch many more such instruments which are essential for heliophysics community here in India. So, and also the bigger mission takes its own life cycle, because it requires technologies to be developed for a bigger missions. So in between these big missions, if we capitalize on these small satellite missions, and that will enhances the science capability of our country to the next level. And as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya-L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting.